Hi everyone, this is Ramalinga Prasad Kuppa. Welcome to my channel Pharma World. Today's topic is Part 1A of Schedule M of Drugs and Cosmetics Act, Clean Room Requirements. This section of Schedule M of Drugs and Cosmetics Act 1940 and Rules 1945 is specific to the requirements of facility for manufacturing of sterile products. The infrastructure, clean rooms, water usage should be designed in such a way to ensure that the sterility conditions are maintained from start to finish of manufacture of sterile products. Let us understand the requirements in detail. Requirement Part 1A Specific requirements for manufacture of sterile products, parenteral preparations, small volume injectables, and large volume parenterals and sterile ophthalmic preparations. Manufacturing of sterile products is critical in terms of control of microorganisms. So, additional precautions must be taken for such activity to ensure sterile atmosphere throughout the activity. These drug products are sensitive and administered into the body other than through mouth. There are 12 sections which prescribe various requirements for manufacture of sterile drug products and APIs. Let us see the details in these 12 sections. Since sterile products are sensitive in nature and directly goes into the bloodstream, it is very critical to maintain hygienic conditions throughout the manufacturing activity. Obviously, hygienic conditions should be maintained for manufacture of all such products to avoid contamination from microorganisms. Buildings and civil works. Section 2 prescribes the requirements of buildings and civil works. This is the first and foremost focus. The buildings and civil works should be able to support a clean and insect-free, microorganism-free environment. The design should be in such a way to have restricted entries into the sterile areas. This section prescribes how the civil structure should be constructed with a focus to maintain the facility with clean environment and free from cracks. Walls, ceiling should be impervious with the manufacturing activity and the exposed surfaces should be non-shredding. Wall to floor, wall to ceiling, corners should be curved to make the cleaning process easy and effective. If it is designed vertically at 90 degrees from floor to wall or wall to ceiling, there is a possibility of accumulation of previous product dust and it becomes hard to clean. The cleaning will be still complex when the product residues dry out. Self-leveling epoxy flooring is recommended. This avoids minute invisible cracks on the floor. This epoxy seal spreads uniformly. The construction of walls and floors should be in such a way to avoid too many joints that could accumulate product residues. The electrical sockets and any other process required fittings should also be flushed into the walls. There should not be sinks and drains in the classified areas of grade A and grade B. The furniture used in the sterile manufacturing area should be easily washable. Stainless steel furniture is recommended. The furniture should be rust resistant. Any other hard and resistant materials may also be used. Appropriate airlocks, pass boxes should be installed. Water and steam supplies, entry and exit controls for the operators should be restricted. Location of services like water, steam, gases, etc. should be designed in such a way that their regular or breakdown service or repair will not pose any threat to the integrity of the facility. Water lines should not leak at any point in the sterile area. The entry into such areas should be restricted. It may be achieved through an automated system or by following an effective SOP. Personal welfare areas like restrooms, tea rooms, canteen and toilets shall be located outside and separated from the sterile product manufacturing area. This is important. The food and other items could compromise the aseptic conditions of the area. So, such areas should be away from the sterile areas and easily accessible. It is also important that such areas are maintained clean and dry always. Continuous supply of water and once use disposable paper napkins or hand dryers should be in place in such areas. Air handling system. Section 3 prescribes requirements of air handling system. Air handling systems are very critical for maintaining dust-free, filtered air in the sterile manufacturing area. The product quality would get compromised if viable and or non-viable particulate matter are beyond the approved specifications. So it should be controlled through proper air filtration through several grades of filters, starting from coarse filters to final HEPA filters. Based on the criticality of the product and manufacturing type, the air handling systems should be designed. It is recommended to have separate air circulation and filtration systems for each type of sterile manufacturing. Separate ducting, separate inlet filters, separate outlet filters, return filters, etc. should be provided. For sterile products manufacturing, the air quality should be class A, B, C, and or D. This is important to know. Class A is the most stringent with a maximum of 100 non-viable particles larger than 0.5 microns are allowed. Here, the number 100 is particles per cubic feet. It is also expressed as particles per cubic meter. The number will be 3500. It is a simple conversion factor from cubic feet to cubic meters. Similarly, for class B, it is 1000, for class C, it is 10,000, and for class D, it is 100,000. There are also specific requirements for viable particles. That is the requirement for microorganisms. The number of air changes should be 20 at a minimum. This is for the comfortable working atmosphere for the persons working over in the sterile area. It is the measure of 20 times air replacement per hour from the closed area. There should be at least 1.5 mm water gauge pressure differentials from one room to the other. There should be a provision to measure the pressure differential throughout the activity to establish that the manufacturing areas are maintained as per the requirement. Unless there are product specific requirements, temperature and humidity in the aseptic area shall be at 27 plus or minus 2 degrees centigrade and relative humidity at 55% plus or minus 2 respectively. This is a generic requirement. These conditions are required for protection of the product and comfort of the operators working over in the sterile area. Environmental monitoring. Section 4 prescribes conditions for monitoring the air handling systems of clean areas. Section 4 is supplementary to Section 3. This section prescribes requirements for monitoring regularly. Following are the recommendations. A. Particulate monitoring in air 6 monthly. B. HEPA filter integrity testing, smoke testing yearly. Particulate matter monitoring and HEPA filter smoke test will help to establish the integrity of the filters. If the HEPA filter is damaged, both these tests A and B will fail. C. Air change rates 6 monthly. D. Air pressure differentials daily. The air changes and the pressure differentials tests will help to establish the performance of the inlet and outlet air pumps. Temperature and humidity daily. The temperature and humidity monitoring establishes the performance of the air conditioning system. Microbiological monitoring by settle plates and or swab in aseptic areas daily and at decreased frequency in other areas. Bioburden monitoring will evaluate the presence of microorganisms in the sterile area. Monitoring of bioburden will be less stringent in supporting areas and more stringent in core areas. Outdoor clothing should not be used for sterile areas. Street clothes are not safe for use in sterile operations. There will be a lot of dust and other microorganisms accumulated on those clothing. So it is necessary to change over to clean area clothing after cleaning up of hands and feet in the rest area before entering into the sterile areas. The clean room clothing should be sterilized before use. Also, such clothing is once use only. After the shift activity, the used clothing should be disposed of to the laundry. The clean room clothing for sterile areas should be of synthetic, non-shedding type and tight weave material. Synthetic clothing are less susceptible to contamination when compared with the cotton clothing, easy to wash and sterilize. Since they are made from tight woven materials, they are stronger when compared with the cotton clothing. Garments shall be single piece with fastening at cuffs, neck, and at legs to ensure close fit. Trouser legs shall be tucked inside the cover boots. This design is to avoid any accidental ingress of human air or any other excretes from the body that could go into the product containers. It should be designed to either include a hood, head cover, or a separate hood which can be tucked inside the overall. Pockets, pleats, and belts shall be avoided in garments. Zips, if any, shall be of plastic materials. Garments with damaged zips shall not be used. Pockets and pleats can accumulate product dust in the fine gaps in the pockets and the pleats. Also, any sharp items like pens, staplers, or papers that may be carried in the pockets could accidentally fall into the product containers, which could go into the product unnoticed. Metal chips are not recommended as they can rust over a period of time. Only clean, sterilized, and protective garments should be used at each work session. Section 5 further prescribes that the garments should be protective to avoid contamination of the product, and the operator from exposing to bulk quantities of drug products or APIs. Gloves should be made of latex or other suitable plastic materials and shall be powder free. Gloves should be tightly fit to the operators. Powder free gloves should be used to avoid contamination of the drug product with external powder dust from the gloves. The footwear should be of suitable plastic or rubber material and shall be daily cleaned with bactericide. Footwear should be suitable for use and comfortable to the operator. Records of all these activities should be done contemporaneously. Safety goggles or numbered glasses with side extensions should be used inside aseptic areas. These shall be sanitized by a suitable method. This is the prescription of Section 5. Suitable safety goggles should be used. It is recommended to use non-folding type safety goggles. Numbered glasses means power glasses. Sanitation. Section 6 prescribes for sanitation. There should be detailed system and procedure for maintaining the sterile conditions. The aim of sanitation is to ensure that the area is maintained free from microorganisms. General cleaning till the area is visibly clean is a basic step of sanitization. The cleaned areas should be sanitized by any chemical treatment. Sanitization could be done by wet method or using disinfectants. Detailed training on cleaning and sanitization methods should be imparted. The training should include cleaning of hard to reach areas, the CIP equipment, the COP equipment, etc. Different sanitization agents shall be used in rotation and the concentrations of the same shall be as per the recommendations of the manufacturer. To make the sanitization procedure effective, it is necessary to rotate the usage of disinfectants frequently. Formaldehyde or any other equally effective fumigant is recommended for fumigation of aseptic areas or after major civil modifications. There are other alternative fumigating agents available, but this is a time-tested method to sanitize the areas by fumigating with formaldehyde. In addition to routine fumigation, it is necessary to fumigate once again after any modification or changes to the civil structure or the equipment. Hand spray disinfectants should be used for personal hygiene before and after carrying out the sterile activity. Equipment. The special equipment required for manufacturing sterile products include component washing machines, steam sterilizers, dry heat sterilizers, membrane filter assemblies, manufacturing vessels, blenders, liquid filling machines, powder filling machines, sealing and labeling machines, vacuum testing chambers, inspection machines, lyophilizers, pressure vessels, etc. The construction material used for the parts which are in direct contact with the products and the manufacturing vessels may be stainless steel 316 or borosilicate if glass containers are used in the manufacturing. And the transfer tubing should be capable of being washed and autoclaved to make it sterile for use. All these equipment should be qualified for DQ, IQ, OQ, and PQ. Necessary procedures, SOPs, should be in place to operate correctly. The operators should be trained thoroughly on the intricate operation of the equipment. Suitable and fully integrated washing, sterilizing, filling lines may be provided depending upon the type and volume of activity. This is the prescription of Section 7. For such equipment, the CIP cleaning should be effective to ensure removal of remnants of previous product residues effectively. Water and steam systems. Sections 8.1 to 8.9 prescribe various conditions for water generation and distribution. Requirements for potable water, purified water, water for injection, and water for non-injectable sterile products are described in these sections. The water system should be well maintained to ensure that the water used in the manufacturing should be free from pathogenic microorganisms, endotoxins, and pyrogens. For sterile products manufacturing, these conditions have to be maintained always. The water system should be sanitized at about 80 to 70 to 80 degrees Celsius by circulation system. This is the best option for sanitization of water storage and distribution system. For generation system, hot water circulation may not be possible always. It may be necessary to use chemical sanitization methods. Water for injection shall be stored in steam jacketed stainless steel tanks of suitable size, and the tank shall have hydrophobic bacterial retention with 0.22 micron vent filters. This 0.22 micron filters in the vent avoids the ingress of microorganisms. Manufacturing process. Classified clean room facilities should be designed to meet the sterile conditions of the product. Classified means that the areas should meet requirements of each class. For example, class A, class B, class C, and class D in terms of various parameters that were discussed in earlier slides. Bubble airlocks, sink airlocks, cascade airlocks should be designed depending upon the type of the product manufactured. Bubble airlock protects the core area from the external contamination. Sink airlocks protect the background areas by containing or sinking the possible remnants of the product. Cascade airlock will have different pressure differentials from one to the other adjacent area. WHO guideline on clean room designs provides a very intricate detail. This guide also provides pictorial depictions of various types of airlocks. Bulk raw materials should be monitored for bioburden periodically. This is to ensure that the input materials are not carrying any objectionable microorganisms into the product that is being manufactured. Preparation and storage of binding solutions must be based on the stability or retention period data. How long the prepared solutions should be used in granulation should be decided based on their stability or shelf life. Other important items. Section 10 prescribes details of terminally sterilized form fill seal units. This section also describes various methods of sterilization. Details of this section 10 are not discussed in detail within this video program. We will discuss at an appropriate opportunity. Section 11 prescribes conditions for product containers and closures. Section 11 prescribes cleaning and sterilization requirements for containers and closures used for sterile products. Containers are generally made from glass or plastic. Closures are stoppers or seals for the containers. All the containers and closures should be sterilized before use. The quality of the containers and closures should be able to withstand the process of sterilization. Section 12 prescribes requirements of documentation with a detailed list. Section 12 describes the requirements for documentation. In GMP, objective evidence is in the form of a written document. So it is a must. This report should contain details of batch number, lot number, inputs, outputs at every stage, starting date, completion date, temperature and humidity records, preventive maintenance records, inspection records, etc. There is a big list of 34 items as evidence for execution of the batch. I hope that this brief explanation on the requirements of Part 1A of Schedule M are understood for sterile manufacturing activity. Check whether or not these conditions are met for your facility. Thanks for watching. For more videos, please do subscribe, like and share. Also, please leave a message in the comments box for any further support. Thank you.